Namaskaram, friends. Now I'm going to today I'm going to start on the technical discussion. Share some of my views on technical discussion. This is basically a presentation focused or targeting the student community who are learning computer science. So this is going to be more of a technical session, basically a series of technical sessions. So let me start on this with this agenda today. Let me share my screen. I assume you are able to see the screen. Okay. So good morning. So today we are going to discuss about the secure software engineering. As I said, this is these sessions are targeted as an introductory session for students of computer science, be it BTech, MTech, or BSc, or BCA, or MCA kind of students who want to understand from industrial or professional side of things. Okay, so the larger agenda that I'm going to address as part of the series of videos uh, will be focusing on these areas in this topic. So first, we'll be discussing the basics of computer science. As I said, this is addressing the students. Second, it is going to talk about the fundamentals of software engineering and deep dive into the software engineering processes, specifically SSDLC, DEVSECOPS, CI/CD pipeline. All these from a traditional perspective is what we'll be sharing first. Traditionally means what is currently happening, and from a non-AI perspective. And then we'll at last we'll touch upon the AI related um, concepts and practices, best practices uh, related to secure software engineering. So with this agenda, let's start with the computer science fundamentals. Here we will be discussing the domain of computer science, the historiographical timeline of its evolution, and the future roadmap. If you take the domain of computer science, it typically involves multiple subdomains or branches. So what here is indicated is just a very high level sample. It is in no way an exhaustive list, and I mean not even a representative list. Just to give you an idea of different domains here, the theory of programming languages, algorithms, data structures, artificial intelligence, big data, hardware, etc. Right now, taking another perspective into the domain of computer science, they can broadly be classified, unlike any domain of science, into theoretical and applied aspects. So the theoretical computer science focuses on the core theoretical frameworks, the underlying math or mathematics under it, the physics under it. So all these concepts of hardcore pure science aspect of computer science, the is what the one of the branches of computer sciences, which is. So here, if you look at, you'll see the mathematical models around it, the algorithms around it, okay, and and then there's another side which is the applied computer science, which is more related to the engineering side of computer science, which will include both the hardware engineering, software engineering, infrastructure engineering, etc. So there are various branches and sub branches within each of them, as indicated in this picture on the right side, which has been taken from the internet. Moving on, just to give a top-down approach, is that from a career point of view, both these domains, as I talked about, whether it's the applied science or the theoretical science, have their own career opportunities. Yeah, as you can become in the domains of artificial intelligence, the domain of software engineering, databases, etc. From applied science. Similarly, from a theoretical science on theory of computation, algorithms, the programming language theory, semantics of programming languages, quantum computing, all those kind of areas are another areas where there is more of the theoretical aspects that has to be researched, etc. So again, I mean, expanding the thought process. If we have theoretical computer science, the different specializations are including algorithms and data structures, which is the backbone of today's AI, data science, and all the domains that we are talking about around Chat GPT, Gen AI, etc. Right. So then there is the automata theory and formal languages. This is again a very important aspect, so particularly with the natural language processing, natural language understanding, prompt engineering, context engineering, etc. So quantum computing is another very, I mean, very important and emerging space. And corresponding career opportunities, you can get into a research scientist kind of a role, or you can get into a designer role or a specialist kind of a role. So these are all just examples here. So, and depending on the kind of role that we are focusing on, there are different skill requirements, basically math or physics or engineering backgrounds. And then programming or software development is another area where you can focus on the programming languages itself as a specialization, or on the software development lifecycle, software engineering, or on the project management around that, or the operations, the DevOps kind of a thing. And similarly, there are different skill sets needed here. Uh, then you can take on the architectural role from a system side, which will include for embedded systems, hardware engineers, operating system level, etc. Okay, and there are a lot of certifications around them also. People can also focus on or specialize on the networking side of the computers, including the basic role or cryptography, security, network security, etc. Okay, or they can take into the database side, or the data information systems, or enterprise information management systems, big data systems, data mining. So there are multiple areas within. You can become a database architect, you can become a data scientist, you can become a database administrator. So different roles around managing data, content specialist. So there are multiple. So today data is not just textual data. We have multimedia data, which includes audio, video, images, etc. So one can get specialization in creation, management, governance around these data. Then there is the hot domains of artificial intelligence, deep learning, machine learning, uh, generative AI, agentic AI, all these emerging space in terms of artificial intelligence. Then there are human career and interaction and graphics related. Uh, roles where you can specialize as a designer, game designer, 3D graphics, virtual reality, augmented reality. All these are domains where we can specialize. And interdisciplinary applications like bioinformatic algorithms, digital humanities, etc. These are all again very niche or specialized areas where one can focus in building their career. Moving on, I just wanted to share a mind map of the different domains that we talked about, which includes the system architecture, scientific computing, numerical methods, ethics, scientific visualization, data management, neuroformic computer, typical software engineering, theoretical foundations about computers, which, basic focus on logic. Or graph algorithms, how best to sort, searching techniques, etc. Um, okay, or it can be on the networking side like cyber security, presentation testing, cryptography, etc. So this gives you a mind map of the different domains and subdomains within the computer science. This is basically a different perspective of what we saw earlier. Moving on, let us look at the history of computer science from its earlier avatars to its latest avatars. So, I mean, history plays a very important role in understanding any domain, any discipline, because we will know what is the path we have traveled, and that will help us understand our future trends also. So it started with 1936, where Alan Turing starts talking about the computability in his famous research paper. And then we move on to 1945, where Newman came with its own stored programming logic. So, and then 1946 ENIAC comes in. 1950 Alan Turing proposes the limitation game theory, which is basically a game turner, actually the all famous Turing test, which is still very very relevant today, although there are other alternative ways of testing. But this is a very very important milestone, particularly for AI space. Then comes artificial intelligence, starts way back in 1956. So today we are in 2025. So you can imagine that how many years of AI we have. So if you look at the computer science itself from 1936, the journey of computer science formally starts. So which means that from 1930s to 2030s, in 2030s we will reach a century. So, and AI, the thought process was seeded from 1950s, and then we have various milestones. So Dennis Ritchie, the father of C programming and a Unix language, great contributor to Unix language, brought in a, a fundamental change in which the programming happened, and C caught on like fire when it comes to programming. My career, for example, started with Unix, C, C++, on Corva kind of technologies. Um, Okay, then there is some improvements on the domain name system, how uh, we started creating web addresses. So the networking um, got its importance, and then Linux uh, brought a new revolution again. So from the closed systems, earlier originally all the vendors of computer science, basically the hardware vendors like the HP, IBMs of the world, they had their own proprietary operating systems also, and but that was standardized through POSIX in during 1971, using Unix, which from a closed system or proprietary system, the era of standardized open systems for operating system came. Unix was a pioneer in that space. So based on Unix, which is a POSIX standards compliant system, Linux branched out of Unix, and Linux is now even today one of the most popular operating systems. In fact, I would say that majority of the production workloads or the production servers across the globe run predominantly on Linux or Windows, and mostly with Linux, except for those applications which run on Microsoft based technologies, which use Microsoft Windows as the backbone. Okay, so then moving on, there is other breakthroughs from AlexNet. Okay, then Apple launches it, then Google comes in. Okay, so then comes here foundation for, I mean, we are all jumping time zones. So 2023 with GPT, which is a major milestone, we'll call it as the AI revolution. So this I mean, this histographical mind map provides you basically the continuum of progress that we have been having in the domain of computer science. So this is another view of the same. So wherein again, I just wanted to give a different perspective of that. We have the pre-foundational aspects of it. Okay, there is the ADA, the Turing machines. Okay, and then there is in 1937 a computer. So Altons of Berry came to the first electronic digital computer. 1943, there are colossal computers. So 1940s were the birth of computing. Okay, and then 1950s was theory of languages. So it was UNIVAC 1 in 1950s, Fortran, and then data mount, Lisp. Okay, then came integrated circuit. Then came the systems evolution, which include the dawn of personal computing. So from all corporate computing are huge mainframe servers or AS400 kind of a servers. The concept of personal computing came down. Similarly, supercomputers also came around during the 1970s. Okay, so and then we saw C emerging. Here we have what is highlighted here is the C++ part, which came in 1980s. Okay, then World Wide Web comes around 1989, where the internet is open for the public. Okay, so the 1990s internet age, where internet spread like fire. As I talked about Linux again, the open source revolution, Java, which again brought in another kind of revolution from a language perspective. So while C brought in one kind of revolution, C++ took it to the object-oriented style, where instead of a process or procedural language or process oriented thinking or procedural thinking, we started thinking in terms of objects in C++, where object oriented thinking was a paradigm for the programming design, which I would say is another preliminary stages of our today's way of artificial intelligence, where we are trying to mind upload all concepts that we found in the real world into the digital space. So ontological mapping of the real into the digital area, right? All this is based on the object oriented concept, where the physical objects uh, are simulated or emulated in the digital space as part of the design. So the first milestone was from C++, and then Java took over within a span of 10 years or so, where it not only brought in the object orientation, but also brought in the concept of write once and run anywhere, which means that it brought in the platform independence. Through their virtual machines, Java virtual machines, where they converted into bytecode, and you can actually port it to any platform, on a Windows platform or a Linux or a Unix or any kind of a platform, and run the same thing, which was not that easy in those days. Um, so then again, the great milestone of Deep Blue, a computer um, against a human intelligence in chess championship. Okay, so then came Google search, where the as part of the internet search. Then comes the mobile world, where the mobility becomes a very important. So you carry a computer in your mobile. So it was the era of smart computers. Uh, Okay, and then Web 2.0, from regular standard web to Web 2.0, where the concept of social networking became a very, very important uh, delivery channel. So from a regular website development, you started building a lot of social networking sites, which are even today very dominant. Okay, then comes the AI renaissance, right from the IBM's Watson, AlexNet, then the Docker containers is more from the cloud side. But from the historical point of view, it comes under this, wherein the cloud computing became a very important thing. So from typical on-premise managed hardware infrastructure, there was a cloud-based management, right from AWS, and then others pitched in, like my Azure, then more recently Google, and today we have a variety of players, including Oracle and other players, providing their own solutions of cloud computing. So, and then moving on, we have the next frontiers in terms of Chat GPT, Google Gemini, and other areas of artificial intelligence specialization. This is again another perspective of historical milestones. So from history, now you're moving to the future. This is again a very, this is not a very, I would say, exhaustive projection or a foolproof projection. This is basically one of the area kinds of projection where it says that what in the next 10 years, what will be the areas of specialization, like something called as edge cloud governance, artificial intelligence, neomorphic computing, then towards general AI research. So that is one area where a lot of focus we will be spending. We will be looking at each of these topics in terms of what is general research, AI augmented systems and formal verification. For example, we will be talking about AI augmented software engineering as part of this course. So, like that, these are some of the trends wherein the next few years there will be focus. So, in terms of theoretical computers, programming, software architectures, of course, quantum computing, all these are some of these areas uh, that we need to focus on. So this is another view of the future. So I have a better resolution here. So it talks again in terms of the different futuristic sustainable computing is one area where we'll talk about carbon negative things. Then there is the biodegradable hardware, which is another important domain where a lot of research is happening. Okay, energy harvesting, zero waste technology, etc. These are all more in terms of, what can be called the sustainability models. Then biocomputing is one area where a lot of research is happening. Synthetic biology. So I think we are all. I mean, the roadmap of AI is towards transhuman singularity, supporting digital twins and other concepts, right? So all these are helping us take step by step towards that larger goal of uh, super intelligence with transhumanism and other things, right? Uh, then there is where cognitive enhancements, DNA data, etc. Okay, then network side evolutions, space-based internet is there, neomorphic networking, entanglement network, quantum teleportation, brain-computer interfaces. Uh, okay, then haptic or holography, emotion-aware systems, direct neural networks interfaces. Okay, so coming to cybersecurity, quantum restraint, self-healing networks, AI-powered threats, zero-trust threats, uh, homomorphic encryption, etc. Then generative AI related things, so embodied artificial general intelligence, okay, self-improving, self-aware intelligence, artificial consciousness, artificial emotions, AI integration, etc. So coming to quantum computing, we have quantum supremacy, then NISQ applications, quantum error correction, etc. So this is again another perspective of the future trends in the domain of computer science. So with this, then we conclude the basics of the computer science. Now we will move on to the next topic, which is secure software engineering as part of the next video session. Stay tuned for it. Do share your feedback. It will help tune it, and do. I mean, any constructive feedback will always help mutually. Thanks for all your support. Stay tuned. Please support this one and uh, subscribe to the video. Thanks, YouTube channel. Thank you. Hari Om.